So now let's continue with the final part of the chapter, in which we are going to discuss about the upthrust and the buoyant force. So the other name for the upthrust itself is the buoyant force, and the property of all liquids to exert a force in the upward direction on the body which is submerged inside is known as the buoyancy, and the force that it exerts in the upward direction on the body which is submerged in the liquid is known as buoyant force. So here we have a stone. So this is the stone and this is the spring balance, and we are going to measure the weight of the stone in air, right? So the weight of the stone in the air using the spring balance turns out to be W1 newtons or gram force or whatever it is. But the moment you submerge this inside the liquid, this liquid has a tendency to exert an upward force on this object or the stone, due to which this object becomes somewhat lighter and the weight over here, which is recorded in the liquid, decreases. This weight is known as apparent weight. Apparent weight is the weight of the body in liquid, which is always less than the weight of the same object in the air, right? And that is due to the upthrust. So I may say that the upthrust is, say for example, FB. So if I call, suppose 20 Newton is the weight, then here you will get slightly less reading, say for example 16 Newtons, and this amount of the upthrust depends upon three factors which we are going to discuss. So what is the reduction in the weight? So weight in air minus the apparent weight, that is the weight in the liquid, weight in air minus the weight in liquid turns out to be 4 Newton. So this 4 Newton itself is the upthrust or the buoyant force. Okay. Now there are three factors which are responsible for the change in the value of upthrust. By the way, I would also like to share one thing with you all, that suppose the upthrust is to be shown, right, in the diagram, then it is this point. This point is the center of the submerged part of the body. That is known as center of buoyancy. Center of buoyancy. So center of buoyancy is a point where the upthrust acts on the body in the upward direction. So please don't show the force vectors everywhere on the body. It has to be shown at one point, that is the submerged part of the body, the center of the submerged part of the body. So if I may say that this is an object which is this much inside the liquid, this is the part of the body which is inside the liquid, then the center of the submerged part is the center of buoyancy. This is center of buoyancy, and the upthrust acts in the opposite direction, I mean in the upward direction at that point. Correct. So let's watch two short videos that confirms the presence of the upthrust. Small piece of thermocol is floating on the surface of water. Using a pen, I am going to push it inside and leave it gently. You can see that the upthrust pushes the thermocol up. So here we have a 2 kg weight, a spring balance, and a water in a container. So we are going to hook up the spring balance with the 2 kg weight. So the mass recorded is 2 kg, so 2 kgf would be the weight. Now I am going to immerse this inside the water, and the effect of upthrust is felt. Due to the exertion of the upthrust, the weight in the liquid decreases, and it turns out to be somewhere around 1.735 kgf. So the weight in the water decreases as a result of upthrust. Let's discuss the factors affecting the upthrust. The first one is the volume submerged. So say for example, if the whole stone is inside the liquid, so this is liquid, and say for example the same stone is only half inside the liquid. So over here the volume immersed is the full volume of the stone, whereas over here the volume immersed is half the value of the stone, right? So here the upthrust is going to be larger, here the upthrust is going to be smaller. So more the amount of submerged volume, a small thermocol piece, more is the value on the surface of water. Density using of liquid, I am pushing say for example you have a stone which is inside the water. You can see that as it goes up, the same stone is inside the oil. So this is water and this is oil, right? We know that the density of water is 1 gram per centimeter cube, and approximately the density of oil is 0.8 gram per centimeter cube. So over here also there is upthrust, over here also there is an upthrust, but the upthrust exerted by the water is larger than the upthrust exerted by the oil. That is due to the fact that more denser liquids, they exert larger upthrust. The third is the acceleration due to gravity, that is G. Here I must say volume immersed. Here I must say density of the liquid in which the object is submerged. Please understand that the upthrust does not depend upon the density of the solids which are submerged in the liquid. It only depends upon the density of the liquids. Now suppose you go to moon. Over there the value of acceleration due to gravity is 1/6 of that of the earth. So over here the upthrust value will be less. So I mean to say that you take a container, immerse a stone and filled with water. Over here on the earth the upthrust is, say for example, F. If you take the same container with same stone and the same liquid, that is water, on the moon, then over there the upthrust decreases by a value of 6. That is due to the fact that the value of G affects the upthrust. So I may summarize this by giving you a formula, but in grade 8 this formula uh, is not to be asked, but still I should say that you please remember density of liquid, volume immersed times G. This is the formula for the upthrust. Okay, and larger the upthrust, lesser will be the weight in the liquid. Okay, now let's take some applications of the flotation on the basis of the density and upthrust. So over here we can see a submarine, and this is the ballastic tanks or ballast tanks. Now these ballast tanks, they have their special doors. This is the door, and if we open up the door, then the water starts flowing in. If the water starts flowing inside the ballastic tanks, the mass of the submarine increases. So that means the volume of the whole submarine is a constant quantity, right? Which means the density is equal to mass upon volume. And if the water is being allowed in, the mass increases, density increases, the density of the submarine increases, and slowly and steadily it starts going down. Now, when the submarine wants to go up, it will empty its ballastic tanks and the water will be pushed out. Water will be pushed out, mass will decrease, volume remains constant, and the density of the submarine decreases, and hence it flows up. So the density of the submarine is not constant. It will change depending upon whether it wants to go up or down. The same case happens with the fishes. Now fishes have a very special organ known as swim bladder. Shark is the only fish that doesn't have a swim bladder, but you might be interested how it goes up and down, right? It has a special fatty liver that regulates that does the job of the swim bladder. Now what does a swim bladder do, guys? See, the fishes, they drink the water in which they stay. Now the water goes out of the gills and the oxygen is filtered in. So more the oxygen which is getting collected in the swim bladder expands. So the volume of the fish increases, the mass of the fish almost remains constant because the weight of the air is negligible, right? So the density is mass upon volume. There is a very negligible increase in the mass, but there is too much increase in the volume, so the density decreases. And finally, the fishes, they become lighter and then they start swimming up. They go up. In the same way, when they expel out the air from their swim bladder, the mass remains almost the same, volume decreases, the density increases, and finally the fishes can go down. Now, let's take up a very small topic, that is the effect of temperature on density of solid, liquid, and gases. See, if you have a solid or a liquid or a gas, if you provide heating to all the three, we know that interatomic forces are very large in case of the solids. So there is little expansion. Over here, there is comparatively larger expansion, and the largest expansion is seen in gases because the atoms, they attract with less amount of force. So when you give the heat energy, there is too much of expansion. So over here also volume increases, and the volume increases by a very large quantity, which means the density decreases. Here also the density decreases, and here the density decreases by a very large amount. So in short, when you heat up the solids or liquids or gases, the volume expands, the density decreases, and that is what the impact of the temperature. So temperature increases, volume increases, density decreases. Now this doesn't happen with the water between 0 to 4 degrees Celsius. We call that as an anomalous expansion of water. Now, see guys, I would like to ask one question over here that's little bit related with the thermal expansion. Okay, so suppose we have a steel plate and I carve out two small holes. So this hole has a radius r1, this hole has a radius r2, and the distance between two holes is small a. Now when I heat this plate, what's going to happen? Which of these distances are going to decrease? That is what the question is. So take a pause and think over and then answer. All right. So let's understand what happens is when you heat up, the expansion happens. Volume increases, thermal expansion happens. Now, since these two holes are also the part of the plate, so the holes also increases in the size. This becomes R1 dash, R2 dash, and of course R1 dash is greater than R1, R2 dash is greater than R2, and the distance becomes A dash, and A dash is also going to be greater than A. So the answer is all distances they increase, none of the distances they decrease. It is the photographic magnification, guys. If you still have any doubts, please do comment in the comment section. Now let's take the example of the sea breeze and the land breeze. So here we have an handsome hero which is on the beach, and this is, say for example, the sun. Now the sun shines equally on the sand as well as the water, right? So after say few hours, this sand also becomes hot, the water also becomes hot. But the specific heat capacity of the sand is less than the specific heat capacity of the water. Which means, please don't take too much of tension in these words. Just remember that the sand gets heated up faster compared to that of the water. And when it comes to cooling down, the sand also becomes cold faster than that of the water. So those substances which have low specific heat capacity becomes hot and cold fast. So that means the air which is just above the hot sand also becomes hot. So now this is hot air. Now hot air, I must say, hot air has larger temperature. T is larger, so volume expands, density decreases. So this hot air rises up. So the hot air goes up. And here comparatively, we have cold water. So the air which is just above the cold water is also cold. This is cold air, which makes this as a high pressure zone and this as a low pressure zone. So now the cold air goes from high pressure to low pressure and it replaces the hot air which is over here. So this James Bond which is standing over here will feel the cold air coming from just above the water, and that is known as sea breeze. So the cold wind coming from the sea towards the land is known as sea breeze, and this happens during the daytime. Just the opposite happens in the night time, right? Now what happens is, guys, since this sand becomes more cold because it cools down faster, so over here you have air which is cold. Now the water takes time to cool down, so this is comparatively hot water, and here the air above is also hot. So hot air rises up, creating a low pressure region. This cold air, since it is denser, creates high pressure region. So from high pressure to low pressure the air flows. So that means the cold air coming from the land towards the sea is known as land breeze. Now, these are all the effects that are being caused due to the variance in the density. So this was low density air, this was low density air. So low density air rises up, right? And this phenomenon is sometimes also regarded as convection currents that we will study in later in detail afterwards. So this is the concept of land breeze and sea breeze on the basis of the difference in the densities. So I hope guys you have understood the whole chapter. Please do ask your doubts if you have any. Thank you very much for watching the video.